numbers on 3 and 4 are actually just like 1 and 2. They present very differently. There's one more step involved in 3 and 4, but they're actually the process of solving is the same. We're solving a quadratic equation, which means like all of these, if they were kind of put in the right form and graph, would be a U-shaped parabola. You're searching for the x-intercepts. You just have your devices put away, ready to work. I can come by and grab them. If they're on your desk, I'll come by and grab them from you. Put them in your backpack. Oh, that gets me all the time. Okay, so we're going to square root both sides. So the opposite of squaring something is square rooting. It completely undoes the operation. So like inverse. If I want to square the left, I also have to square the right. So the radical and the exponent cancel. And when we solve by square rooting, we always need to put a plus or minus sign. You square root both sides, you need that plus and minus sign. Alright, my goal is just to get x alone. I just want to know what x is. So we'll add 3 and add 3. And x is 3 plus or minus whatever the square root of 80 is. Technically, you solve for x. This tells you the value for x. However, we just went last week simplifying radicals, so you need to make sure before you finish your problem that you leave your radical in simplest form. So simplify the radical at the end. So I'm thinking of different numbers that 80 can be divided by. It could be 4 and 20, 5 and 16. And 16 is useful because 16 square roots. Square root of 16, put it right in front. And so now it's 3, then the plus or minus sign, then the 4, square root 5. That's your answer. Don't do 3 plus 4, don't do 3 minus 4. Just keep the 3 separate. If you do like 4 and 20. Well, so if this wasn't in simplest radical form, I can't give you 100% full credit, but I don't want to take much off. Because really, all I want to know is that you understand the process of solving by square rooting, right? Now, on your test, there will be questions where you're not doing all of this, where it's just simplifying a radical. And so simplifying the radical, that's where you get all your credit for doing it completely. But here, if you go through all these steps, but you just left it 80, or maybe you made it 4 and 20, or 2 and 20, I just take a little bit of credit off. So there's only one minimal difference between 1 and 2. What's the only difference? Yeah, there's just this is 80. This is 81. You wouldn't think it would matter much, but it does. 81 is a perfect square, which makes kind of the ending of the problem appear different. So I'll square root both sides. And then the x minus 3 has been taken away from that exponent. And now this is plus or minus 9. There's no radical left over. 81 is a perfect square. Trying to get x alone, add 3 over. So I'm at 3 plus or minus 9. So because I can actually add 3 to 9 and do 3 minus 9, you have to go further. So on this problem, you have to keep going. Whereas on this problem, you can't keep going. So you need to kind of make a little note and think about it. No radical means keep going. So I'm going to get my two answers. I'm going to do 3 plus 9. And I'm going to do 3 minus 9. So my answer is 12 and negative 6. So if it's a perfect square, you can keep going. If it's not, you're stuck. I don't know. Yeah, correct. Yeah, plug 12 into the original problem and it works. Plug negative 6 in and it works. Because 12 minus 3 is 9. And negative 6 minus 3 is negative 9. And most importantly is if we were to graph that, these are the x-intercepts. Other good questions. Okay, so the next two problems are honestly just like those. They just present different. Here you got to factor this. And it's going to factor to look just like 1 and 2. This is 2 answers too, yeah? Just like that's 2 answers, this is 2 answers. Okay, let's try it when the problem looks a little bit different. So for these, you have to factor first. Factor the left side. We practiced yesterday. So you're looking at what multiplies to 100 and adds to 20. 10 times 10. 10 times 10 is 100. 10 plus 10 is 20. That's factored. So it's best to write this instead of these two matching binomials. Anything times itself you can write with an exponent of 2. And now the problem looks just like 1 and 2, square root both sides. Yeah. So x plus 10 is plus or minus the square root of 17. Right here. The radical bar and the exponent just cancel each other out. It's like if I was to say add 3 and then subtract 3, it would mean nothing. Square rooting and squaring means nothing. They cancel. Or were you asking me where this one goes to here? That one would show up if I were to FOIL it. So we're just rewriting that. Let's just start with factor. We did this. So yesterday's class we started Bellwork with factoring, just as a review before we just started rewriting like that. Subtract 10, and x is negative 10 plus or minus the square root of 17. 17 is a prime number. There's not a lot you can do with it. You surely can't square root it. So that's your answer. Okay, number 4. Number 4 has bigger numbers, but it factors easily because this number is square roots and this number is square roots. So if A and C are perfect squares, when you factor them, you got your 2 sets of parentheses. The square root of 25 is 5. So I'll write the square root of the first one in. The square root of 49, 7. Write your 7 in. It's a minus sign here, so we do a minus sign here. That's called factoring a perfect square trinomial. Square root by factor, factor by square root. Anybody have a question about that? It almost seems too easy, doesn't it? Just the square root of 25 and square root of 49. It almost seems too easy. There is a little rule, there's a little check that has to happen mathematically number-wise. Is that 5 times 7 doubled has to be the middle number. Did that happen here? What's 5 times 7? 35 doubled is 70. That has to be true. If that's true, then that factor is quick and easy just by square rooting. So you see that on the SAT written in really complicated ways. They'll call this A and B, and they'll ask you about 2AB. A times B is 35 and 2AB is 70. So that has to work when you factor that way. Alright, so we'll write it as a binomial squared. Guys, have you gone from there? Go ahead and take off from there. Square both sides. See how far you get. Square both sides. Square root of 200. I'll add 7 first. And I still have a 5 in front of x. 7 plus or minus the square root of 200. And then when I divide by 5, this whole thing divides. And it's x equals 7 plus or minus the square root of 200 over 5. And this is like all of the steps done. That's a lot of steps. Getting x alone. But for full credit, your radicals have to be in the simplest radical form. So 200. 102 is our best bet. 7 plus or minus, I'm going to think of 102 instead of 200. Oh, there's a 5. Cross out the 100 and put a 10 in front. And this is now 7 plus or minus 10 square root 2 all over 5. Full credit right there. Full credit. But I should show you, I'm obligated. I feel obligated to show you how different this could show up in different places. This fraction could be separated. So it's 7 over 5. And then the plus or minus would go here. Like sometimes it'll separate, put the plus or minus in the middle. Then you could actually reduce the fraction on the right. So it's actually 7 over 5 plus or minus 2 square root 2. Looks completely different than that answer. Sometimes students will be like, I don't know, Mrs. Baldwin, I swear I did every step right, but my answer doesn't look anything like the answer in the book. And I'm like, well, they've just simplified it differently. So this is full credit, but you'll often see it typed in a book looking more like that. They're equivalent. Separate the fraction and then reduce either fraction if possible. Okay, so let's take a look at your homework. Let's see how you did. You're factor and square root. Yeah, we are. Actually, we're gonna use the note handout from Friday and Monday. So we're gonna go over homework and then we're gonna go back to this guy that we started on Friday. Continued yesterday.
Listen here.
Check it out. Oh, you know what? You know what? I don't like how the decimals are here, so I'm gonna show you the radical answer. Totally bummed out they put decimals. In geometry, did you guys do decimals or simplest radical form? Where'd you say from? Raise your hand if you did simplest radical form in geometry. Raise your hand if you did decimals. None of y'all can remember. Raise your hand if you can't remember radicals, square root in geometry. Okay. You know when you did it was well the Pythagorean theorem, a squared plus b squared plus c squared, and the distance formula. You probably don't know about decimals and square root. I'm gonna rewrite these answers for you. So number 5, you should have had. -2 plus or minus the square root of 2. Not that decimal. Number 6, you should have had 1 plus or minus the square root of 5. Number 7, you should have had 3 plus or minus the square root of 7. And number 8, you should have had -8 plus or minus the square root of 15. Do those look better than those decimals? Yeah.
Yeah. I do know.
There's kind of a place for decimals. This is not it.
This one in you. You have to spring and you go through. That's sad that he's young like so long. Still sad. Why? Nothing. Okay. That's so funny. Ellen.
Let's show your answer.
That's it, because it's obviously a bit. Don't act like this is a bit. That's the design of the book. What's up?
I don't tell you to work, so this is one of the things, which is most likely gonna be us.